Alrighty, so let's get this party started. So, hey there, everybody. My name is Brandon Gorakhnauth. I'm a marketing engineer at Hamamatsu Photonics, and I handle our laser and sintering products for Hamamatsu USA. So, we're a global optics and photonics company, but my intention today is just to give you an overview of thermal light sources and different specifications related to sintering. So, mainly just to get your noggin jogging about different light sources that can help with sintering and photonics. Before jumping in, here's a list of things I won't be covering today. So I won't be covering printing methods, substrates, or inks. Either you're an expert yourself, or we have guys like Max to handle that for us. What I will be covering today is light sources in context to the sintering step of printed electronics. So if we imagine, let me, this thing isn't working. Okay, here we are. I need to point at it. So if we imagine printed electronics to have a bunch of different black boxes for processes, I'll be focusing on that end there, that orange box, the sintering stuff. And I'll be covering all of the light sources or different thermal sources that could be used for this process. Okay, so during my 15 minutes of fame, we'll touch on the following topics. Oh, this thing is terrible. Let's see. Okay. Yeah, so we're going to touch on the following topics. We're going to touch on introduction to light sources and light source specifications, different light source types, and also light source selection guide just to help you on your merry way. Okay, so let's jump right in. So put simply, we'll explain what a light source is. A light source is a source of photons, electromagnetic radiation that exhibits the behavior of a particle and a wave. That includes everything from light bulbs to LEDs to lasers, X-rays, and even ovens. In this way, like we're superficially familiar with the idea of a light source because we're using our eyes to see right now. But what we aren't all familiar with is the different specs of light sources that contribute to photonic sintering, or even printed electronic sintering in general. Let's see. Okay, so the first parameter that we're going to examine is a spec called spectral radiance. Spectral radiance is a measure of the amount of light emitted by a light source at a specific wavelength per unit area per unit angle. In other words, this parameter tells you how much a light source emits at different colors or wavelengths. If we imagine a light source such as like this television display, it's an array of LEDs emitting RGB. If we wanted to see the spectral radiance, or if we wanted to see the amount of radiance coming from like a section of it, this would tell us the red, green, and blue values associated with that section. Let's see. Next, we have spectrum. This is the next parameter. The spectrum of a light source generally represents the different colors of light emitted by a light source. We have separate graphs here. Starting from the left, I'll explain what they all do together. For graph number 1, this describes the irradiance of the light in respect to wavelength. For this example here, this light source is emitting a very flat range of colors. So we have blue all the way on the left at 400 nanometers and red all the way on the right at 700 nanometers. For graph number 2, this describes the energy of the photons. Shorter wavelengths are higher energy than the longer wavelengths. And then these graphs kind of come together in graph number 3. This describes the number of photons being emitted by the light source. In this case, the radiance of each wavelength is the same between red and blue wavelengths, but there are actually less photons coming in for the blue side because these are higher energy photons, so there's less actual photons needed to reach energy parity with the red side. The next characteristics are irradiance and spectral irradiance. Irradiance is the total power of the light received per unit area and considers all wavelengths. Spectral irradiance, on the other hand, is the power of the light received per unit area per wavelength. So this measure is wavelength dependent.